Hello, everyone. Uh, so today we're gonna talk about BGP. It's a prerequisite for cluster mesh with Calico. So, um, if you don't remember our last session, we talked about cluster mesh with Submariner, which I think the recording is available in YouTube and LinkedIn. So whichever is your platform of choice, you can see it there. Um, Let me get the chat going. So today we're gonna build a cluster mesh, or at least try to prepare our clusters for a cluster mesh, but without Submariner. So if you don't know, or if you didn't know, it is possible to create a cluster mesh with only Calico. Calico offers a dynamic routing protocol, BGP, which you can utilize and have two or more clusters join together, propagate their routes, and figure out where the information should go or shouldn't. There are a lot of configurations when it comes to BGP. I bet you've heard that the internet is network of networks. One of the main routing protocol that makes internet the network of networks is BGP. Basically, all everyone who's using a computer and is connected to internet is somehow navigating through BGP autonomous numbers to get to a point or to be seen. So an ASN or autonomous number system is similar to an let's say post station. So whenever somebody wants to figure out if a route exists, they send that packet to the representing ASN, and from there, some great postman or postwoman will take it to the destination. Anyway, so let's get started by creating a couple of clusters. All right, so hopefully I'm sharing the correct window. Yes. By the way, if you're in the chat and you got questions, let me know. If you're here, just drop hello or where are you from. That would really help. I'm trying to see if I can be famous in all over the world. So let me know. All right. So first cluster is. Oh, by the way, I'm gonna post the link to all the commands that I'm running here in chat in a bit. All right, so here, if you are in LinkedIn, I have to come to LinkedIn and where is the live session? All right. So, oh, we got a customer from Denver. Hello, Vinky. So here is, I think I have to change. All right, so here are all the commands that I'm gonna run. So Enki had a question. So not just Calico, but cluster mesh can be created by any other CNI, like Cilium. Well, again, our previous session was Calico and Submariner. So it doesn't really matter what CNI you're using. As I referenced in the previous session, it all comes to the features and the scalability that you want. So depending on what is your environment, if you want like a couple of data planes, one data plane, if you're looking for scalability, if you have limited resources, these are all factors. But you are correct. I think currently you can create cluster mesh with any CNIs. And if the CNI that you are running, let's say Planner, is not capable of doing that, you could use another open source project like Submariner, previous session. So this is just a shout out to my previous session. So if you watch it, that's all there is. And you can run cluster mesh with it anywhere. All right. All right. So a couple of things. Now I got two clusters here. Cluster 1 and cluster 2. In order to navigate between these two clusters, I'm gonna use a -- context. If you're not familiar with -- context, it's just an argument in kubectl that allows you to switch between clusters without changing your default context. So you could basically run a command in one cluster, then use the context to run it in another. So kubectl config view. So in your config file, if you have more than one cluster, you would see them inside the clusters. This is the Kubernetes API server that kubectl will talk to. Here is the current context. So if I run kubectl get pods, it will show me all the pods that are currently inside cluster 2. This is because my current context is cluster 2. Now I can change that cluster, but that would add some more commands to put in. I know about you, I'm a bit lazy when it comes to these sort of stuff, so I'm just gonna use find C1, and here are the pods for C1. So during this presentation, if you see context, just be aware I'm switching between clusters. If you noticed, my cluster doesn't have a CNI. That is why core DNS and local path provisioner are just pending. So let's add Tigera operator and configure Calico. All right, so usually when you are trying to install Calico, you need to use an installation resource. The installation resource is required to configure the operator. Now, most of the time you would see above Calico network something like BGP and disabled. Keep in mind, if you have BGP disabled, no matter what are the changes that you are doing, the BGP subsystem or bird binary will not run. So make sure if you are typing BGP in your installation, it is enabled if you're trying to use BGP with your Calico. And if you omit it, by default, BGP is enabled. So we just omit it, and the default configuration will take care of that part. So here, now we need to figure out where is our installation, what is the progress for our installation. For that, we could use kubectl get Tigera status. Tigera status is a command that will be added after you install the operator. It's within the CRDs that the operator provides, and it just gives you a lot of information about all the components that are that Calico uses in order to function. So installation, as you can see, at the moment it is progressing on cluster 2, I believe, because there is no context for this command. Any other questions? Well, I guess you guys know more about BGP than me, so yay, that's always a plus. All right, so Calico is available, but API server is not. If you remember, there was a binary file Calico cattle. Calico cattle was was an application, standalone application that could interact with Calico API group. So since Calico is following the Kubernetes standards, everything is written inside the projectcalico.org API group. And in order to communicate with that, you need to extend Kubernetes API server. So by default, kubectl cannot interact with that API group. So API server here expands the capability of your Kubernetes API server, and it allows kubectl to get information about, let's say, Calico global network policy stuff. I think it is GMP then. Yes. It is global network policy. There you go. It can be a demo if something doesn't go wrong. So yay. We got that thing covered too. All right. So by default, BGP is enabled, but it's not configured. As I said, in order to turn on BGP, you need to give it an autonomous system number. That configuration is stored in BGP configuration. Easy, right? So here, what I'm gonna do is, for my first cluster, I'm gonna add the 65001 as the autonomous number. One thing to note here, there is log severity screen, which is it's going to be the BERT log. So BERT is the binary that is going to do all the BGP peering and everything related to BGP. So this log severity will let Bird know how good you are with reading logs. If you turn it to debug, it will just spam everything that is happening, error info, and similar to every other Linux logs, it's gonna ask, oh, we got another customer from Romania. We're talking about BGP, so you haven't missed much, but let's go. So if you turn this log to info, you will get log level before info and info. If you turn it to warning, it would be info, warning, and that's it. If you turn it to error, it would be info. You see where it's going, right? It goes on and on and on. And debug is like the chattiest version. Like you basically say, just tell me everything that you can think of, even if it's not in the news. All right. So now that we got the BGP configuration, both our clusters have an AS number. Now, AS number will be their identity. So if a route or if a packet needs to go to that route, it will go to that AS number. But AS number on its own is not that helpful because, again, if it was like that, imagine if I just turn on an AS number inside the internet. Well, then everybody will see everything from, my computer without specifically saying that I want to see like the routes that Reza is offering. So next part is going to be BGP peering. So in order to do that, I'm going to need the IP address of my cluster, cluster nodes. To be specific, I'm looking for control plane. So here it's going to be on I'm going to copy these two and quickly create document. Oh, hello, Sensius. Hopefully I pronounced it correctly. Sorry if I didn't. All right, so now that we have the BGP configuration, we need to specifically say who needs to connect to where. So in order to do that, I'm gonna create a BGP peer in my first cluster. Now, in my first cluster, I'm gonna say the peer IP, which would be the IP address visible to my cluster. Here is 172. Again, every command that I'm typing here, I posted in the comment. Just go there. Everything is local. You don't need to buy fancy equipments or anything. You just need a computer that can run some commands, and that's about it. Like 8 gigabytes of RAM. Anyway, so I'm here. I'm telling my Calico that I want my BGP peer to be that IP address, and it needs to represent you with that AS number. Done. So the next one is going to be the same thing, but in cluster 2. In cluster 2, I'm going to say, hey buddy, I need to create a BGP peer. The peer IP is that, and the AS number is that. since this is a live demo, we're gonna check stuff again. So yes, control plane 02, 02, and hopefully we got stuff. Now, one thing to mention here is that if you remember that BGP configuration file that we created, I told you about I talked about some configurations being set to default. Now, one of the things here is full mesh. By default, Calico runs a full mesh BGP peering. So what does that mean? Well, let's delve into it. First of all, we need to figure out if the things that we have done are actually correct, or did we change anything? So in order to do that, again, because we have the Calico API server, we can create another unique resource, Calico node status, for both of our nodes in both clusters. Here is the cluster 1, and here is the cluster 2. Now, creating these two resources allows us to run a very interesting command, which is Calico node status. Calico node status is equivalent to Calico cattle, think node status. It will be Calico cattle node status. Yeah, these two are almost identical. Let me know in the comment if they're not. So here we see some stuff. It's not that much. It's telling me that there's an update every 10 seconds. Last update was 2 seconds ago, but again, I don't see that much. So let's see it in details. All right, so I got a lot more information. Let's start at the top. So items in this manifest, which is Calico node status, is name of my control plane. So I know which node status I'm getting. This is for cluster 1 control plane. Now, agent, BGP, and routes were things that we added when we created Calico node status. You can actually change these, like delete the ones that you don't want, depending on how you want to configure your cluster. Again, the best part about Calico is you can basically change everything, and everything works. So router ID is the IP address of my cluster node, and state is ready. So BGP is actually running. So Bert, the agent who's going to take care of BGP, is up and running. That's a good thing. It's both running in version 4 and version 6. So IP address v4 and IPv6. If you're running dual stack, Calico can handle that too. Under BGP tree, you will see the established v4, which is at the moment 2, established v6, 0, that we don't have any, not established v4, and v6 is 0. So we get to this non-established, but there are ways that you can say, you know what, there is this IP pool, which is very important, and it has sensitive information. So you can use inside your Calico IP pools, you could actually say, don't export these IP addresses and into my BGP propagation. Now here we have a node mesh. So as I said, when you turn on BGP, Calico will establish a BGP between its nodes, but here is the one that I'm more interested in. This is the one that we created, 04, if you remember. So our global peer is actually working and the state is established. So we got some BGP communication and hopefully we'll see some routes. So here I got 1801 from Ethernet 0 kernel. So source type means where I got these IPs. Well, source type BGP peer. BGP peer. So it seems like things are working. You can see all other routes, but the ones with node mesh and BGP peer are the ones that we are very interested in. Now here, as you can see, it's the bulk of the network or the CIDR that is advertised in BGP peer. If you come down, since we created two Calico node status, we get the second one for the worker node. Now in worker node, there is something wrong. As you can see, the global peer is active, but it's not established. So basically, we should not be seeing any BGP peer routes here. I know about you, but that smells like a problem to me. So let's evaluate this in a little bit more detail. I talked about BERT. So BERT is the binary that is doing all the BGP magic for our cluster. There is actually a way to directly communicate with BERT and figure out what is going on. So here is another troubleshooting tip. You can run BERT.co and that will give you access to a BERT command line, which will tell you about the routes, about the peers, about everything else that you want to know. One more thing to mention for your troubleshooting journey before I say I correct the problem that I created is that you can do kubectl logs, go to your Calico node pod, take a sip of water, and figure out what is actually going on. So these are the errors or notifications that BERT actually points out. So here, as you can see, unexpected connect from unknown address 172.18.03, and it's trying to just like connect and connect and connect. Coming back to what I said earlier, by default, Calico is using a full mesh architect. So when you turn on BGP, this node to node mesh enabled is true. Now, how did I know that? Well, spoiler alert, before creating this whole presentation, I had to came into the documentation. So the moral of the story is, no matter what you're doing, just check the documentation for that project, figure out all the things that are in there and see what are the actual representation for it. So here it says full BGP node to node mesh. Only valid on the global default BGP configuration. It's true and false. It's a string, and ta-da, by default, it is true. All right, so let's go back to terminal and check. I got 2 more questions. So what's the difference between global and mesh in the routes? All right, let's come back here and YAML. I think here would be the best place to figure it out. Now, as I said, when you turn on BGP, Calico itself tries to communicate with the other nodes through BGP. That's the default behavior because of the variable that I showed you, the node to node mesh. So this one. Now, what is the difference between... All right. So what is the difference between node mesh and BGP peer? BGP peer are external routes that are propagated into your environment. Node mesh are internal routes that clusters, your participating nodes in a cluster will tell to each other. Is node mesh a BGP position between nodes in a cluster? And yes, basically, as you put it in the first question, a global peer is an outside cluster. A node mesh is between the node participating inside your cluster. All right. So let's get back to figuring out what I've done. All right. If you remember, we saw one of our BGP sessions was stuck in active mode. And to fix that, we need to create another BGP peer for our worker nodes. Here, I'm just communicating with the control plane node. So what I need to do is get all the IP addresses. Actually, you know what? I could do better. So first one is control plane. It's going to be 02. Second one is the worker node. It's going to be 03. This is my cluster 1, replacing the BGP. Oh, I need to create one, not to replace one. Duh. All right. And I need to create another one for this worker. this again. So BGP worker 2, cluster 2 is gonna connect to this one, which is 03. That is correct. Now, two is gonna connect to this one. Uh-oh. All right. So 03 needs to come here, and 05 needs to come here. Now I can do a replace. All right, so cluster 1, it needs to connect to worker 2 with ASN number 2. All right, that is known. And cluster 2 needs to connect to cluster 1 worker node. And we can come back here. C1 worker status show YAML. And we got the BGP here. Hopefully it is established. Again. So, crisis averted. Oh, we're running out of time. Now, I can go even further and come to control plane and run IP route. So here, you would see BERT, which is, again, the BGP agent that Calico is using, and you will see IP CIDRs that are not local to my cluster. So right now, if you look, this 10, 20, 245, 1164/26 is actually known via BGP. Now, there is one problem here. Now, the problem is, let's explore it. If I create a pod in my second cluster and wait for it, all right, and wait for its IP address, you can see it's 10, 245, 245, 131. Now, this is actually in around here. Yes, it's in this IP CIDR. So what happens if I create a service? Because services do have another IP address, which is another range. So these two are different. So let's see what happens. Now, here, the IP address is 1097 and it's /16, so we can actually that 1097 suffices. So here, if you look, there seems to be no service propagation. If right now I try to connect to this service, it will not be possible. Well, let's try that 3. I'm gonna use NetShoot Pod. It's an awesome open source container. If you are just search Nikolaka Netshoot or Nicole AKA. That would be way better. So, running a pod here with Netshoot image at some point will give me a container, unless Docker says you're not allowed to pull images anymore. We'll see. It's going to be one or the other. Oh, good. All right. So if I do IP route get here, it says, well, I got a default gateway, so I have to send it there. But if I try to curl it, nothing comes back. If I go to the default gateway and do IP route get, it will tell me, well, I also got a default gateway and I'm sending it there. But as we know, this is not a public IP address. So when it gets to the router that is connected to internet, it will go like, dude, this IP is not reachable. I'm just sending it out to the trash bin. Now, how we can solve this problem? So here, what I can do is, in my BGP configuration, where we introduce the AS number, I can say, well, you know what, Calico? My cluster has a service IP CIDR. That is one of the things that I want for you to propagate to. If we do that, the next time that we are doing IP route, we should be able to see 1097.0016 through BGP. Now, again, we can explore this with the commands that I showed you before in more details. So basically, YAML, and somewhere around here, we should be able to see 10 something here. So 1097.00 is viewable in here and here. So gateway is actually one of the nodes inside the other cluster. What else do I have here for you guys? Oh, so one more thing to point out is I need the Firefox thingy, and we need to open up Kubernetes documentation. All right, so traffic policies. You can set a traffic policy. This traffic policy will tell your CNI of choice what to do with that traffic. Now, in terms of Calico, where was it? It's in the services. All right, so by default, Calico is set to cluster. It's another page. Oh, here. No, the sticky. In some scenarios, not this one either. Oh, this one. Okay, So again, documentation is your friend whenever you want to find something. So right now we're advertising our cluster service side by using BGP. Now, here there is two way for a service to be propagated in this scenario. One is cluster, the other one is local. Now, cluster is the default. If you don't annotate your service, that will be the one that's going to be used. So it will, as it says, it give you an equal distribution of traffic among all pods running service. Possible unnecessary network hops between nodes for ingress external traffic. When packets are rerouted to pods on another node, traffic is source netted. Destination pod can see the proxy node's IP address rather than the actual client IP. So basically, it adds an extra hop, and it will get rid of the originating IP address. Now, if you annotate your service to local, then it will avoid the extra hop. So better for apps that ingress a lot of external traffic, and traffic is not source netted, so actual client IPs are preserved and traffic is distributed among pods running service, maybe imbalanced. So again, it comes to you which one you want to choose, but I would say local has more benefits in most scenarios because that source IP address, something that you can preserve, but Calico eBPF data plane 2 is something unique and very useful. So it all, again, depends on what you desire to have. And depending on your configuration, you can run it with Calico. So that would be our stream for today. I'm not sure if you guys have any other questions or not, but let me know. Oh, I forgot to. So in LinkedIn, hopefully you can see the link to. All right, so link to the Calico Live GitHub. If you like it, give me some stars, and that will be the best incentive. Changes. Wait, I did change something to replace where I shouldn't supposed to. Let's just fix that. So git comment minor fixes, and you should be able to run all the commands by following this. Oh, Wenky. No worries. If you got other questions about other sort of Kubernetes stuff, let me know. While I might not be able to answer them, I can find you some pretty clever engineers here who like know everything. It's my cheat sheet. Like every time I'm facing a problem, I just go to them and ask, and they're like, yeah. So our Calico user Slack is one of the places that these engineers are always monitoring. Other sort of stuff, GitHub issues. I cannot say how many times GitHub issues have saved me. So if you're facing some troubles, Slack for the open source project that you're working, and GitHub is the best way to approach people. With that being said, I don't think it will get any better. So thank you for viewing and goodbye.